Okay, hello students, welcome back. This is going to be section 2.5 to 2.7. We're going to cover measures of center, mean, median, mode, and standard deviation today. Okay, so let's get into it. Share my screen. Okay. Okay, 2.5 to 2.7. Okay, one, I can calculate the following measures of center location, mean, median, and mode, and then again, we're going to also use standard deviation here. Okay. Okay, for the mean, the population mean, we add up all the numbers and then divide by the total in the population. For the sample mean, we add up all the numbers and divide by the number in the sample. Okay, and that's the sample mean. Okay, the means are easily influenced and skewed. Okay, by skewed distributions and outliers, most appropriate for symmetric and unimodal distributions. Okay, so if it's symmetric and has one mode, we'll want to use the mean as the measure of center. Okay, for median, think middle number. Okay, we already have seen the median. That's, you know, Q2 or the 50th percentile. Okay, if a number of data values is odd, then median is the exact middle number. Okay, and we've seen that before. If the number of data values is even, then the mean is the two middle numbers. Okay, it's the average of the two middle numbers. Okay, the mean is resistant or robust, means that it does not change much when the data includes outliers and are less affected by skewness. Okay, the mode, what's the mode? Think most. Okay, the value that occurs the most. If no value is repeated, then there can be no mode. Data can also be bimodal or multimodal. So you can have more than one mode. Okay, let's look at example one here. Let's calculate the mean, median, and mode for the sample data. Okay, for rounding, carry one more decimal place than is present in the original set of values. Okay, except for the mode. So for the mean, okay, we're going to label this a sample. So we're going to do sample mean, which is X bar, and that's going to be 22 plus 22 plus 26 plus 24 plus 23. Divide that by the number of items here, which is 5. Okay, so I'm going to add these numbers up. Let me pull out my calculator real quick. Okay, so this is 22 plus 22 plus 26 plus 24 plus 23, and that's 117. And I'm going to take that number and I'm going to divide it by 5. So I get 117 divided by 5 is 23.4. Okay, so that's the mean, okay, or the average. So this is the mean. Okay, the median is the middle number. Okay, so in order to get the median, I have to put these in order. Okay, they're not in order. 26 is not the median here. Okay, so I have to put these in order from smallest to largest. So that's 22, 22, 23, 24, and 26. So the median is 23 there. Okay, so the 23 is the median. Let me box my answers. Okay, and the mode, which number occurs the most often? That would be the 22, and that's the mode. Okay. Okay, let's flip the page and move to the next example. Okay, calculate the mean, median, mode for this data sample. Okay, so this, again, I probably want to put these in order right away. So let me do that. Let me order this from least to greatest. This is going to be 35, and then it's going to be 37, 42, 44, 49, and 54. Okay. I'm going to put it in order. I'm going to find the mean. Okay, so the mean is just going to be add them all up and divide by the number of items there are. And that's 6 in this case. So I'm going to go 35 plus 37 plus 42 plus 44 plus 49 plus 54, all over 6. Okay. Let's plug that into the calculator. So I'm going to clear that. 35 plus 37 plus 42 plus 44 plus 49 plus 54. Okay, it's 261. Divide that by 6, and I get 43.5. So this is 261 over 6, or 43.5. Okay, so that's the mean. Okay, the median. Okay, so what's the middle number here? Well, there isn't a middle number. There are 2 middle numbers. There's the 42 and the 44. So if I have no middle number because it's an even number of items, then I take the 2 middle numbers. In this case, it's the 3rd and 4th values. And I'm going to add those 2 together, 42 plus 44 over 2. Okay, find the average of the 2 middle numbers, and that's going to be 86 divided by 2, which is 43. So the median was 43. Okay, and then what's the mode here? Well, there is no number that occurs most frequently. They all occur the same frequency. They all occur once. So we would say that there is no mode. Okay, we can use technology to help us solve some of this stuff. We'll go through and look at, okay, well, how would we use StatCrunch or the TI? They have the TI-36X Pro here. I'm going to use the TI-84 in this class. So for the TI-84, I have both of those on my computer here. So I'll bring up and show, okay, how are we going to get the stats for StatCrunch, and how are you going to get the statistics on the TI-84? Let me show you how to do that real quick. Okay, so for StatCrunch, let me bring up StatCrunch. Let me bring up the web page here. Okay, so here's the web page for StatCrunch, and I'm going to sign in. Okay, so if you want StatCrunch, you can purchase this. I think it's about $15. You'll need either StatCrunch or a calculator that does statistics. So StatCrunch is the cheaper way to go. Okay, so sign in. Okay, unless you already have a calculator. So. Okay, so now I'm signed in, and I'm going to go to open StatCrunch, and it's going to open StatCrunch for me. Okay, and I'm going to enter the values that we had in the previous example here, and I want it to find, some statistics for me. Okay, so let's do 54, or let's put them in order. Let's do 35, and then 37, and then 42, and then 44, and then 49, and then 54. Okay, and it's saying if you want to use StatCrunch, then you're going to go to Stats. Okay, and then you're going to go to Summary Stats, and then you're going to go to Columns. Okay, and then you're going to click on Variable 1. Okay, that's the column we're going to look at, and then there's a bunch of different things that they'll give you here. Okay, the statistics that you can choose. The ones that are coming up right now are these. Okay, our 5-number summary. our mean and our standard deviation. Okay, so we'll get to what standard deviation is in a little bit. But I'm just going to click compute, and it tells me, oh, look, my mean was 43.5, and my median, it tells me what my median is 43. Okay, so it tells me what my mean was, and it tells me what my median was. Okay, will it tell me my my mode? No, it won't tell me my mode, but you should be able to look at the data and see what the mode is pretty easily. Okay, but this will also tell me my range. It will tell me my min, my max, and it will give me my Q1 and my Q3. So if I want to do a box plot, it calculates the 5-number summary right here for me. Okay. Okay, let's put that away and go to the calculator. How do we do this on the calculator? Okay, well, here's my calculator. And in order to get to this screen, I hit stats. Okay. Here. Nope. Okay. Yes, that's what I want. Okay, I'm going to clear this. Clear that real quick. Okay, so that gives me my key press history. So when I press a key here, it should hopefully show up. Okay, so I'm going to quit out of this. Okay, this is what the calculator would look like if you just booted it up. Okay, and then I'm going to go to the stats key. Okay, and all the keys that I push are going to be highlighted in red. Okay, they're also going to be listed down below. So I'm going to hit the stats key, and then I'm going to hit edit, and it's already highlighted as edit. So I'm just going to hit enter. Okay, and then it has some values here that I had previously. If I want to clear the values, if there's values in your column already for L1, just arrow up and hit clear, and then hit enter. Okay, don't hit delete, because that will delete the whole row or the whole column. And I don't want to delete the column from view. Okay, so I'm going to hit that. And then I'm going to put in my values. Okay, so if my values like before, 35, I'm going to put in 35 and then click enter. Okay, and then we've got 37, click enter. Okay, and then we have 42, click enter. And then we have 44, enter. And then we have 49, enter. And then we have 54, enter. Okay, so now we're going to, now that we have this, I'm going to hit that stats key again, and I'm going to calculate my one variable statistics here. Okay, so I'm going to arrow over to calc now. I'm going to arrow over, hit the stats key to go back. I inputted my values, and now I'm going to hit one variable statistics. Well, it's that first one, so it's already highlighted. So I'm going to hit enter, and then I'm just going to hit enter through the next 3 lines in order to calculate this. So list 1, yes, hit enter. Frequency list, yes, hit enter. And then calculate, hit enter again. So I ended up hitting enter 4 times. That's what that little purple 4 is down there. Okay, and so what does this tell me? This tells me that X bar is equal to 43.5. Oh, okay. And then there's a bunch of other stuff. They give me the standard deviation here, S of X, for the standard deviation, which we'll cover a little bit later, and sigma sub X. Okay, but it also tells me the median. If I scroll down, I hit the down arrow, it will tell me the median. The median was 43. So it gives me the same values. It also tells me the min, the max. It doesn't tell me the range, but it does give me my 5-number summary as well. Okay, so the calculator gives me a 5-number summary, and also the StatCrunch gives me my 5-number summary. Okay. Okay, let's go back to the notes. Okay, let's look at example 3 here. Okay, means from a frequency table. Find the mean of for the population data. Well, we've already put this population data into a frequency table. There are 2 1s, there are 4 2s, and there are 6 3s. How many total items does that mean that there are? Well, I'm going to add up the frequency column here. Okay, so let's add the frequency column. Okay, so 2 plus 6, 2 plus 4 plus 6, that's 12 items. So if I were to count the number of items here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, there are 12 items there. Okay, so 12 items for the frequency. So remember, we need that because we're going to divide by the number of items, and that's 12. And we can use the fact that it's already in a table by, instead of adding all these values, we can make use of multiplication, which is just fast addition. And we can say, well, okay, this is going to be 1, this is going to be 2 1s, this is going to be 4 2s, and this is going to be 6 3s. Okay, so what's 1 times 2? Well, that's 2. What's 2 times 4? Well, that's 8. And what's 3 times 6? Well, that is 18. And so I add all that up, that's going to be my sum. Okay, the sum of the items. So 2 plus 8 is 10, plus 18 is going to be 28 here. Okay, and so to find the mean, we just want 28 over 12. Okay, and it says that it's a population. Okay, and this is the whole population. Instead of X bar, I'm going to go mu. Okay, mu is that, you know, it's the Greek letter. It's a Greek U, and it stands for mean of a population. Okay, so for the mean of a population, okay, or mu, it's called. Okay, it's going to be 28, the total, over 12. Oops, sharing my screen. Okay, 28 over 12. Okay, which is equal to what? 28 divided by 12. Okay. So let me try the stop share one more time. Let's share my screen here. There we go. There's my calculator. So 28 divided by 12 is equal to 2.33. So I'm just going to say that it's approximately 2.3. Okay, so the mean is approximately 2.3. Okay, which should kind of make sense. You know, we don't want a number that's less than 1 or bigger than 3, because all of our data is between 1 and 3. So it kind of makes sense that the mean is, you know, around 2, little bigger than 2, because we had more 3s than we did 1s. Okay, remember, you know, we wanted to keep this thing balanced. So if we did a little dot plot here of 1, 2, and 3, right? So 1, 2, and 3, we had two 1s, we had 1, 2, 3, 4 2s, and we had 1, 2, 3, 4, 5, 6 3s. Okay, and so we can see that the data would be balanced. Okay, balanced at 2.3. Okay, so mu is about 2.3 there. Okay, find the midpoint between two values. We add them, then divide by 2. Okay, so find the midpoint between these two values. Okay, 20. So what's the average here? What's the mean of 20 and 29.5? So that's going to be 20. Okay, or the midpoint, I'll make this M. It really is the midpoint. So 20 plus 29.5 over 2. Okay, go to my calculator. 20 plus 29.5. Okay, now here's a big mistake that students do on the calculator. Okay, when they plug this into the calculator, all they do is 20 plus 29.5, and then they hit the divided by 2. and it comes out wrong. This number here, 34.75, that's a wrong answer. Okay, what did I do wrong there? Well, when I have a fraction, there are what's called implied parentheses. There are parentheses that are implied on top, and then there are parentheses implied on the bottom. We do everything on the top first, and then we do everything on the bottom second, and then the very last thing we do is divide. So if we go to the calculator, what am I telling the calculator to do? Well, I'm telling the calculator to do 20 plus 29.5 divided by 2, but the calculator knows order of operations. It knows to divide before adding. And so it will divide the 29.5 first and then add it to the 20, and we'll get an incorrect answer. So the way that I can circumvent that is I could use parentheses here and go 20 plus 29.5, close parentheses, and divide that by 2. And I get 24.75. Okay. 24.75, which makes more sense than the 30 that I was getting, because if I'm going to take the average between two values that are in the 20s, I would want to end up with a value between the two in the 20s. Okay, I wouldn't want to end up with a value in the 30s. That would not make any sense. Okay. Okay, example 4 here. Estimate the mean. Use the midpoint for each bin to estimate the values in each bin. Okay, so each bin here, the first one is 1 to 1.4. So the midpoint there, I'll just do the first two here, is the midpoint for bin 1 is going to be equal to 1.0 plus 1.4 over 2, which is going to be 2.4 over 2, which is 1.2. Okay, so the midpoint there is 1.2. What about the next one here? This is going to be 1.5. The midpoint for bin 2 is going to be 1.5 plus 1.9 over 2, which is going to be 3.4 divided by 2, which is 1.7. And I could do the same thing all the way down. I would just end up with 2.2, 2.7, 3.2, 3.7, and 4.2. Okay, so now I'm going to use the frequency to get my mean here. First, I'm going to add up the frequency here. I'm going to say that this column is going to tell me, okay, this column is going to tell me how many items there are total. So I'm going to add up this column here. Okay. And the items in this column. So let's do that. 5 plus 3 is 8, plus 4 is 12, plus 1 is 13, plus 2 is 15, plus 1 is 16, plus 0 is 16. So there are 16 items there. Okay, for a total of 16. Now, how are we going to get the total value here? We're going to use the chart and the frequency. We're going to multiply the frequency times the midpoint. That means there are 5 1.2s. So how do I add up 5 1.2s real fast? I do 5 times 1.2. And then I add that to 3 times 1.7. And then I add that to 4 times 2.2. And then I add that to 1, 2.7. And then I add that to 2, 3.2s. And then I add that to 1, 3.7. And then I add that to 0, 4.2s, which is just 0. And that's all going to be over 16 here. Okay. Okay, so I'm going to just add up the top first, find out what that value is, and then divide it by 16. So I like to kind of break things down in steps if I can, because then I don't have to worry about messing up with this big computation. So 5 times 1.2, okay, is 6 plus, okay, oops. back up. Okay, 5 times 1.2 is 6 plus 3 times 1.7, 5.1. Okay, plus 4 times 2.2, that's 8.8. That one's kind of easy. Probably do that in your head. Plus 1 times 2.7, well, it's just 2.7. Plus 2 times 3.2, I can do that in my head. That's 6.4, just double that. Plus 1, 3.7, that's just 3.7. Plus 0, 4.2, that's just 0. Now we're going to do all over 16. And then I'm going to plug this into my calculator. 6 plus 5.1 plus 8.8 plus 2.7 plus 6.4 plus 3.7 equals 32.7. So this is 32.7 over 16. Okay, so we're going to estimate the mean for this, right? So I'm going to say that this is a sample. So X bar here. Okay, so X bar 32.7, right? Yeah, 32.7 is correct. Okay, 32.7 over 16 is going to be approximately what? I'm going to go 2 places past the decimal because I'm dividing by 1 place past the decimal. I'm always going to go one extra place accuracy on my final result. So let's do 32.7 divided by 16 is 2.043. I'm going to, that 3 makes the 4 stay the same. So that's 2.04. Okay, so that's the average for that one. Okay, calculate the mean. Objective now is to talk about the range, the standard deviation, and the variance. Okay, range, standard deviation, and variance. So I can calculate and interpret the standard deviation. Okay, so the first thing we want to do on these data sets here is calculate the mean. What's the mean here? Okay, so X bar is equal to 4 plus 5 plus 5 plus 5 plus 6 all over 5. Okay, so if I were to add these numbers up, 4 plus 5 is 9, plus 5 is 14, plus 5 is 19, plus 6 is 25. So that's 25 over 5. Okay, and so X bar is equal to 5. We'll call this X bar 1 because it's from data set 1. Okay, what about data set 2 here? Data set 2. This is going to be 1 plus 2 plus 3 plus 9 plus 10. And we'll actually find out that this thing will add up to 25 as well. 1 plus 2 plus 3. Okay, plus 9 plus 10. Yeah. 6 plus 9 is 15, plus 10 is 25. And so we get X2 is 25 over 5. And so X bar 2 is also 5. Okay, so we ended up with the same mean, which is interesting. Okay, but they're not the same data. One is very close together. This has what we call a small spread. And the other ones are pretty far apart. We've got 1 to 10 here, and this is a large spread. Okay, and so let's look at that in a dot plot. Okay, so if I did say 0, 1, 2, 3, 4, 5, okay, 6, 7, 8, 9, 10, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, if we look at our data, that's 4, 5, 5, and 6. So let's do a dot plot. 4, 5, 5, 5, and 6. Okay, very symmetric, very balanced, and the mean ended up being at 5. That's the middle at 5. Okay, but notice that again, they're very close together. Okay, the data is very close together. all in between 4 and 6. Okay. Okay, what about data set 2? Well, data set 2 was 1, 2, 3, 9, and 10. Okay, so all the values are different. We get 1, 2, 3, 9, and 10. And what do we notice? That the data is very spread out. Same mean, same middle. Okay, if we were to look at a balance here, these data sets would both be balanced at 5. Okay, so the data would both be balanced at 5. However, one has a small spread, small variation, we call it variation, small variation in the data, and then here we have a large variation. So we'd like a way to get a numerical number that calculates how much variation is occurring, and that's standard deviation. Okay. So in order to understand the behavior of the distribution, we need to understand both the measures of center, which in this case is the mean, and spread, which in this case is going to be the standard deviation. Okay, for numerical data, it's standard deviation. Okay, let's talk about the range real quick. What's the range of the data sets? Okay, well, the range for R1 here, the range is going to be the max minus the min. That's 6 minus 4, which is 2. Okay, so the range on this one is 2, very small range. Okay, and what about R2? The range is 10 to 1, 10 minus 1, which is 9. So that had a range of 9. Max minus min is 9. Okay, so 2 for the first range, whoops, and 9 for the second range. Okay, let's talk about standard deviation now. Okay, standard deviation. So we have population standard deviation, which is just divided by, we add up the difference from the mean to the value and then square it. And then we divide by n, which is the number of items in the population. For population, we divide by n. For sample, it's the same calculations that we're going to do, except that it's now n minus 1. Okay, it's the number of items minus 1 for a sample. Okay, so this is where the formulas are different based on if we're given the entire population or if we're given a sample. Okay. There's more error that's involved in a sample standard deviation, and that's why we have to subtract by 1, okay, to account for that error, okay? Populations are more accurate. If we know the entire population instead of just pulling a sample out of there, okay? They're both approximations, but the population one is a little more exact. Okay, this sigma, what does this mean? This is sigma. What does this symbol mean? It's sigma, and it just stands for population standard deviation. Okay, population standard deviation. What's the X stand for? The X is just the data value. These are all every value in the population. Okay, mu, that's the population mean. And n is the population size. Okay, how many data values do I have? Okay, S is just the letter S, and that stands for sample standard deviation. SD is standard deviation. Standard deviation. X is, again, every value in the sample. Now, every value in the sample. And X bar is the sample mean. And N is the number of items in the sample, or the sample size. Okay, so standard deviation is a measure of spread or variation. Okay, variation. Okay, general interpretation, the data have a typical deviation of, okay, sigma, okay, or S, depending on which one we're using, have a typical deviation of sigma units away from the mean. So on average, we're going to get this value and it's going to be, oh, on average, we are that far away from the mean. It's a measure of how far away, on average, the values are from the center. Okay, are they really close together? Are they really spread out? Okay, calculating standard deviation by hand. Okay, so we're going to calculate the mean. We're going to calculate the difference. We're going to calculate the square of the difference, then the average of the square of the differences, and then the square root at the very end. So we calculate the mean, the difference for each data, then we square those differences for each data point, and then we sum all of those up and divide by the number of items. That's if we have the population. Okay, this is for population standard deviation. We divide by n. If it was sample, we would divide by n minus 1. And then we just take the square root of the whole thing here. Okay, once we get that value, we take the square root there. Okay, so let's do this by hand. Let's see how we would calculate this. Okay, example, calculate the population standard deviation by hand. We have 5, 5, 5, and 6. Well, what was the mean on this? We saw that the mean already, okay, for this population was 5. Okay, the mean is 5. They're saying calling it a population, so we'll go with that. Okay, population here. Okay, so the mean 4, 5, 5, and 6. Okay, the difference between each of these values and the mean. Okay, so I'm going to list out each of the values of the column 4, 5, 5, 5, and 6. And I'm going to subtract 5 from each of these values. That will give me the difference. Okay. So now I'm going to take this 4 minus 5 is negative 1. That's 0. 5 minus 5 is 0. 5 minus 5 is 0. And that's 1. Now what I'm going to do is I'm going to square each of these items. Okay, I'm going to take negative 1 and square it. Negative 1 squared is 1. 0 squared is 0. 0 squared is 0. 0 squared is 0. And 1 squared is 1. And now I'm going to take the average of this. I'm going to add all these values up. I'm going to go 1 plus 0 plus 0 plus 0 plus 1 all over n, which is the number of items here. And the number of items is 5. We get 5. So this is going to become 2 over 5. Okay, so 2 over 5 or 0.4, if you were to divide that. And then what I'm going to do in my last step is I'm going to square root that 0.4. Okay, and that, if I plug that into my calculator, let's do 0.4. We could do, I'll do 2 divided by 5 just to show you that it's 0.4. 2 divided by 5 is 0.4, and then we're going to square root that, and it comes out to about 0.63. I'll go out to 2 decimal places, so about 0.632, right? And then that 2 tells me that that 3 stays the same. So about 0.63 is my standard deviation. So I'm about 0.63 or less than 1 on average away from that mean, which makes sense because, you know, I've got 4 and I've got 6, and that's about as far away from the mean as I go. And so on average, we're about 0.63 away because there are some that don't deviate from the mean at all. Okay. Okay, let's look at our second one here. Okay, calculate the population standard deviation by hand. Okay, again, what was mu? Mu was 5. We calculated that previously. We add them up, divide by 5. Okay, what's the difference from the mean for each of these? So I'm going to go 1, 2, 3, 9, and 10. And I'm going to subtract off 5 for each of these. This is -4, -3, -2, 4, and 5. Now I'm going to square each of these values. -4 squared is 16. -3 squared is 9. -2 squared is 4. +4 squared is 16. And 5 squared is 25. Now I'm going to average these out. I could probably add these up in this column first, and that's 70. If I add all those up, those numbers up, I get 70. Okay, and then I can say, okay, the average is going to be 70 over the number of items, which is 5, and that becomes 14. Okay, so the average here is 14, which we actually call this number the variance, or what we call it sigma squared, which is the variance. Okay, and so then we're going to square root this number to get the standard deviation, or sigma. So sigma is approximately the square root of 14, which is approximately what, oops, on calculator. Minimize that. Okay, so this guy is 14 square rooted is 3.74. Okay, so I'm going to say that it's about 3.74. Okay, or about 3.7. We'll just go 3.7 on that one. Okay, so 3.7. Okay, so on average, where was the mean? The mean was 5, right? So we're like, oh, 5 is the mean here. Okay, that was the mean, the balancing point. Okay, and then on average, we're about 3.7 units away on average, right? So these values are much more spread out than the other values we had, right? They're about, on average, they're about 3.7 from the mean. Okay, the average amount of distance that all the data points are from the mean is 3.7 units. Okay, so that's our measure of spread, how spread out. Okay, what if we wanted to calculate the sample standard deviation? Can we do that? Yeah, we would just do the same. We would do the same thing. We would just instead end up dividing by 1 less than the number of items. Okay, it's the same process. Okay, it's just 1 less than the number of items that we have. Okay, so let's do this one here. What's the mean here? Let's calculate the mean. 3 plus 6 plus 9 plus 10. Okay, over 4. Okay, that's how we're going to get the mean. This is the sample mean. X bar this time. So 3 plus 6 plus 9 plus 10. Okay, that's going to be 9 plus 9 is 18, plus 10 is 28. So this is 28 over 4. So X bar is equal to 7. Okay, so now how are we going to find the difference? The difference is going to be the difference 3, 6, 9, and 10 are from the mean, which we calculated as 7. And this is going to be -4, -1, 2, and 3. Okay. So now we're going to square this. -4 squared, 16. -1 squared is 1. 2 squared is 4, and 3 squared is 9. Okay, we can add these numbers up and divide by the number of items minus 1. Okay, so again, this is a sample, which means that we're going to end up dividing by n minus 1, not n. Okay, not n minus 1. This is the sum. Okay, that little summation sign means sigma. Okay, it's capital sigma. Okay, and it means sum all this up. Okay, so this is, I'll just write out the sum. Okay, so the sum over n minus 1, that's going to be the average. So we're going to go 16 minus 1, or plus 1, plus 4, plus 9, all over 4 minus 1 this time, not 4. Even though there are 4 items, it's 4 minus 1 because it's a sample. Okay, this is a sample. And so this is going to be 16 plus 1 is 17, plus 4 is 21, plus 9 is 30. And so this is 30 over 3, which is 10. Okay, so the average is 10 here. Okay, and then what are we going to do on the last step? We're going to square root that 10. Okay, and so this is S. Don't forget that this is S, okay, or sometimes referred to as S of X. Okay, S, not sigma this time, okay, because it's a sample, and this is going to be the square root of 10, which is approximately what? Let's go to the calculator. Go 10 square root, that's 3.16 or about 3.2. Okay, so S of X is about 3.2. Okay, we're the sample. Okay, let's do one last one here. This is calculate the sample standard deviation by hand again. So this is, we're going to find the mean, X bar, 4 plus 5 plus 7 plus 8 over 4. Okay, so that's going to be 9 plus 7 is 16 plus 8 is 24. 24 over 4 is 6, so X bar is 6. So let's find the difference. 4, 5, 7, and 8 minus 4 minus 6, 5 minus 6, 7 minus 6, and 8 minus 6. This is going to be -2, -1, 1, and 2. That's nice. Okay, and then we want to square these values. So -2 squared is 4. Oops, -2 squared is 4. -1 squared is 1. 1 squared is 1, and 2 squared is 4. So this becomes, if I add these up, that becomes 10. Okay, and then we want to go 10 divided by what? It's 3, not 4. Remember, this is 10 over n minus 1. So this is 10 over 4 minus 1, or 10 over 3. Okay, and then I'm going to square root that number, 10 divided by 3. Okay, and that's going to give me my S. My sample standard deviation is going to be S, and that's going to be the square root of 10 divided by 3. So let's do that. So we want to do the 10 divided by 3 first, because everything's under the square root here. So 10 divided by 3, and then I want to square root it. And it becomes 1.826. So this is 1.826. Okay, or we'll just say that it's 1.8 approximately. Okay, after rounding correctly. Okay, let's wrap things up. How do we do this on a calculator? Okay, calculate sample standard deviation. Okay, so calculating standard deviation using your calculator. Okay, type in data into your, oh, oops, did I skip? No, I didn't. Okay, into your data, and then do one variable statistics, and it should give us, okay, the statistics there. Okay, which symbols though? What are the symbols on our calculator? Well, let's go to our calculator and let's see. I'm going to go back to stats here. Let me clear my key history. I'm going to hit stats. Okay, and then I'm going to click on edit. Okay, so let's go to edit. Just hit enter. And then I'm going to clear my list. So I'm going to click up, clear, enter. And that clears my list. And then I'm going to put in these values that I want to calculate the standard deviation for, right? So let's do the last one. Let's do 4, 5, 7, and 8. Okay, 4, 5, 7, and 8. Okay, so 4, 5, 7, and 8. Now I want to go to the stats key again. I want to arrow over to calc, hit one variable statistics, which is just enter. It's the same thing that we did for the mean. And this says that, oh, your mean is 6. But now look down here. It says S sub X is my sample standard deviation. S sub x is my sample, which is 1.82. So S sub x was my sample standard deviation for a sample. What's sigma sub x? That would be if it was a population. If we had divided by 4 instead of 3, then it would have been a sample, then it would have been a population standard deviation. That gives me that there. So that's sigma sub x. So S sub x is the sample standard deviation, and sigma sub x is the population standard deviation. So let's go back to our notes. Which symbols are there for sample standard deviation? Well, that's S sub x, sample. Now what's for population standard deviation? That's sigma sub x, population standard deviation. Okay. Example 6 says calculate the sample and population standard deviations. Okay. 2, 5, 9, 11, and 25. Okay, so let me show you how you do this on both the calculator and on StatCrunch. Okay, calculate the sample and population standard deviations. Okay, so this is 2, 5, 9, 11, and 25. Okay, so let me make note of that. Okay, let's plug that into, I'm going to hit clear. Okay, to clear my key press history. So I'm going to go back to stats key. I'm going to hit enter, and then I'm going to clear this. Clear, and then enter. Okay, and now I want to plug in my new values here. 2, 5, 9, 11, and 25. 2, enter, 5, enter, 9, enter, 11, enter, and 25, enter. Okay, so now I want to calculate standard deviation. Just hit the stats key, go over to calc, one variable statistics, and hit enter, 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 4 enters. And then this tells me, look, my mean was 10.5. My S sub x is 8.9 or 8.88. Well, let's round to the nearest hundredth, or 2 decimal places. Okay, and our x bar was 10.4. Okay, S sub x is 8.88, and sigma sub x, which is the population standard deviation, is 7.94. So 8.88 and 7.94. So let me note that. So S sub x was 8.88 and sigma sub x was 7.94. Now, what if I didn't have a calculator and I want to do this on StatCrunch? Well, here's how we would do it on StatCrunch. Let's go back to our StatCrunch. Okay. Let's enter our new values here. This is going to be what we did. Okay, and I think I only have 5 values. So this is going to be 2. Okay, and then 5. And then 9, and then 11, and 25. So now we do that. And then again, we're going to hit the stats key. We're going to hit summary stats. Stats key, summary stats, and then columns, right? Now, when if I just calculate the variable 1, it will only give me the sample standard deviation. That's what this standard deviation here says. Okay, I hit column variable 1 to bring up my variable 1. Okay, and then like my column, there you go, variable 1 is populated. And then it has standard deviation. That's going to be my sample standard deviation. So if I hit compute on this, that just gives me the standard deviation here was the sample standard deviation, which is 8.87. Okay, that's if I were to divide by 4 in my calculation, that n-1. If I were dividing by 5, if this was a population, I have to do the same thing, but I have to add in what's called a non-adjusted standard deviation, okay, or unadjusted standard deviation. So I'm going to do the same thing here. Stat, summary stats. Come on, go. Stat, summary stats. Be nice. Columns, and then I'm going to hit my var1 for my variable 1 column, but then I'm going to have to arrow down. Okay, I'm going to have to arrow down, scroll down to where this says unadjusted standard deviation. I'm going to have to add that to the column on, add that to the column on the right. So unadjusted standard deviation, I add that to the right here. Okay, I could also add the standard deviation. Okay, I want to let me, oh, I think I have to hold down Control to do multiple ones. So I want unadjusted standard deviation. Yeah, I have to hold down the Control button on my keyboard. So that's going to give me standard deviation and then unadjusted. Unadjusted is population. Okay, so then I hit compute, and it computes what S sub x was, and it computes what sigma sub x is. Okay, unadjusted is population. Okay, for StatCrunch. Okay. Let's do the next one here. Okay, example below are recent annual compensation amounts in millions of dollars for being a CEO of, this is a sample of chief executive officers, CEO, Ford, Coca-Cola, Intel, and Boeing. Calculate the mean and standard deviation using your calculator. Okay, let's put my calculator here. And I'm going to clear my key press history. Okay, I'm going to go to stats. I'm going to edit this, and I'm going to go clear, enter. Oops, go arrow up and then hit clear and enter. Okay, so I cleared that. Let's go back to my notes to see what, so 17.7, 19.6, 12.4, and 14.8. Okay, so 17.7, 19.6. Okay, so 17.7, enter, 19.6. I believe the next one was 12.4. 12.4. Okay, and then what was the last one? 14.8. Okay, so 14.8. Okay, and then I'm going to hit stats. I'm going to go calc. I'm going to hit enter, 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 4 enters. And it tells me, okay, what's my sample standard deviation? 3.17. Okay, so the sample standard deviation. Okay, so the mean, oh, what was the mean? The mean was 16.125. So the mean was 16.125. And the sample standard deviation, S sub x, okay, is 3.17, I believe. Okay, so yeah, 3.1, S sub x here, 3.17. Okay, so S sub x is 3.17. Okay, so let's say 3.17. Okay, so what does this mean? It says interpret the standard deviation in context of the problem. So these are the millions of dollars that the CEOs are making for their salaries, right? So annual compensation, that's a lot of money per year. Okay, but so interpret this. This says that the annual sorry, my ends are pretty bad right now. Okay, annual compensation, okay, typically varies about $3.17 million from the mean salary of $16.125 million. That's what that means. Okay, example number 8. okay, without doing any calculations, which data set would have the largest standard deviation? Which one would have the largest standard deviation? Well, remember, standard deviation is a measure of spread, how spread out your data is, right? So if I look at the first histogram here, the frequency values here, I notice that I have a lot of data on the edges. Okay, I have a lot of data on the edges. For the second one, all the data is the same. Okay, all the data has the same number of values. Okay, but for the last one, a lot of the data is in the middle. Okay, so the data is more spread out, is largest. Okay, in the first one, it would have a medium standard deviation if everything was the same, and it would have the smallest standard deviation of these three if it's all bunched in the middle. Okay, this means that a lot of data is in the middle. Okay, and so that's how we would do that one. Okay, on the most recent statistics test, the instructor posted the following statistics to the class. The mean was 72.4 and the standard deviation was 11.7. Interpret the standard deviation in context of the problem. Okay, the scores. Okay, typically varied 11.7 points from the mean of 72.4. Okay. Oh, that's pretty good. Pretty good. Okay, that's basically a bell curve. Okay, it's basically a bell curve, right? Where you have the mean as your C's, right? And then you have standard deviations, okay, B's and A's, and then D's and F's. Okay, generally when I curve grades, I'll curve them to the center of about 75 with a standard deviation of about 13. Okay, and that gives me some really nice values to curve with a normal distribution. So, okay, you look down at your test score and you scored 62. Okay, 62. How far off is your score from the class mean? Well, it's about one standard deviation. About one standard deviation below the mean. Okay, do you think your score is unusually low? No, I wouldn't say it's unusually low. Is it low? Yeah, but is it unusually low? Okay, compared to the class? No, I wouldn't say that it's if I was maybe 2 or 3 standard deviations below the mean, then that would be unusually low. Okay, think about the outliers, right? If I was 1.5 away from the middle, right? 1.5 IQRs away from the middle, then that would be an outlier. Okay, we don't really talk about outliers in terms of standard deviation, but okay, we do talk about if something is 1, 2, or 3 standard deviations. If it's 3 standard deviations away from the mean, then that's pretty much going to be an outlier. Okay, and so is it 3 standard deviations away from the mean? No. Okay, is it say a 40%? No, it's not a 40%. Okay, that would be unusually low. The 62, is it low? Sure, but is it unusually low? No. So we would not conclude that 62 is unusually low. Okay.